Hi friend, today I discuss a question from csir NET Mathematics 2018. Question number 70, part C. Booklet code C. Question number 70. Here the question is, consider the quadratic form q1xy equal to xy, q2xy equal to x square plus 2xy plus y square, q3xy equal to x square plus 3xy plus 2y square on r square. Choose the correct statement from below. Option 1, q1 and q2 are equivalent. Option 2, q1 and q3 are equivalent. Option 3, q2 and q3 are equivalent. Option 4, all are equivalent. This question from quadratic forms. So if you not subscribe my channel, please subscribe Study Room Math. So now start. Question number 70. Now the solution. Any polynomial of the form. What is quadratic form? First we write any polynomial of the form q x1 x2 xn equal to summation I equal to 1 to n summation j equal to 1 to n aij xi xj is called a quadratic form. Of order n over f in the n variable x1 x2 xn. So we can find a unique symmetric matrix V equal to Vij m cross n n cross n of order n such that Vij is equal to half of Aij plus Aji. This is very important. So any quadratic form where which is given, then we can always find a unique symmetric matrix B. The increase of B is given of the formula Bij equal to half of Aij plus Aji. So here given that q1 xy is equal to xy. So first we apply this formula. Then we get the symmetric matrix V1 is equal to 0, half and half 0. Since B11 is equal to half of A11 plus A11, here the coefficient of A11, this is coefficient of x square, so this is 0. So 0 plus 0 is equal to 0, and V12 is equal to half A12 plus A21. Now the coefficient of A12 be the coefficient of xy, so this is 1, and the coefficient of yx, So the coefficient of yx is 0. So this is 0. So half. Similarly, we get v21 and v22. Now calculate the next symmetric matrix for the quadratic form Q2. Then we get what we will get 1 1 1 1. And similarly, if we put the value here, then we obviously get this, and v3 is equal to, we get 1 3 2 and 3 2 2. Since v11 is equal to half a11 plus a11 and v12 equal to half a12 plus a21 and also b22. So if we apply this formula, then we get this. Now two real quadratic form said to be equivalent when two quadratic forms are said to be equivalent if they have same rank and same signature. What is rank and what is signature? We discuss here. So when two quadratic forms are said to be equivalent if they have same rank and same signature. What is rank? Rank is the, first we calculate the eigenvalue of v1, v2 and v3. Then what is rank? Rank equal to number of non-zero eigenvalue. If we calculate the eigenvalue, then number of non-zero eigenvalue is the rank. And what is signature? Signature is number of positive eigenvalue minus number of negative eigenvalue. We calculate all the eigenvalue, then number of positive eigenvalue and minus number of negative eigenvalue. Then this is signature. So if you calculate the eigenvalue of v1, first we calculate the eigenvalue of v1, right? Then minus lambda half minus lambda is equal to 0. This is characteristic equation. So lambda square equal to 4, 1 by 4, then lambda equal to plus minus half, right? So what is rank? If we denoted the rank are the number of non-zero eigenvalue. So non-zero eigenvalue are plus half and minus half, so rank is 2. And what is signature? Signature is denoted by small s. So signature is number of positive eigenvalue minus number of negative eigenvalue. So number of positive eigenvalue is 1 and also negative eigenvalue is 1. So signature is 0. Now next, for v2, here v2 is given this. So we calculate first the eigenvalue of v2. So 1 minus lambda 1 minus lambda. This is equal to 0. Then 1 minus lambda the whole square equal to 1. So if we calculate this, we get lambda equal to plus minus. So 1 minus lambda 1 minus 2 lambda plus lambda square minus 1 equal to 0. This implies lambda into lambda minus 2 equal to 0. This implies lambda equal to 0 and 2. So what is rank? Rank is number of non-zero eigenvalue. So here non-zero eigenvalue is only 1. So rank is 1. And also signature is number of positive eigenvalue minus number of negative eigenvalue. So number of positive eigenvalue is 1. Number of positive eigenvalue, this is 1, and minus number of negative eigenvalue. So number of negative eigenvalue is 0. So signature is 1. Now we calculate for V3. Here V3 is given 1, 3 by 2, 3 by 2 and 2. Right. So first we calculate the eigenvalue. So 1 minus lambda 3 by 2, 3 by 2, 2 minus lambda equal to 0. Then we get 1 minus lambda, 2 minus lambda minus 9 by 4 is equal to 0. If we calculate this, we get 1 minus 2 lambda, 1 minus 2 lambda minus lambda plus lambda square minus 9 by 4 is equal to 0. Right. Then we get lambda squared minus 3 lambda minus 1 by 4 minus 1 by minus this is 2 is equal to 0. Right. So what we will get, lambda equal to plus minus so we get 3 plus root this and 2 and 3 minus root this by 2. So what is rank? Rank is equal to number of non-zero eigenvalue. So here number of non-zero eigenvalue is 2, and signature is equal to number of positive eigenvalue, which is 1, and number of negative eigenvalue, this is also 1. So we get 0. Now we check the option. Q1 and Q2 are equivalent. Here Q1, the eigenvalue, the rank of Q1 is 2 and signature is 0. And here also the rank is 1 and S signature is 1. So Q1 and Q2 not equivalent. Q1 and Q3 equivalent. Yes, Q1 and Q3 is equivalent. Here R equal to 1, S equal to 0. And here also R equal to 1 and S equal to 0. So option 2 is correct. And Q2, Q3 are equivalent. Q2, Q3. Here Q2 is, here R is 1 and S is 1. And here 2 and 0. So not equivalent. So this option is wrong. And all are equivalent. No, all are not equivalent. So option 2 is correct. So thank you for watching. Subscribe Study Room Math. Thank you.